because this is a long process and we shouldn't get bored throughout time. We also need to follow up and monitor the whole process throughout time, and we need to offer information about the possible application in further treatments, because this should have to be used in future in different areas. The drawbacks are that the cost is very high. Sometimes this is cumbersome both for the hospitals and the patients and their families. There are no tools for a systematic analysis of the results. The systematic evaluation of exercises is still not enough. And what we are really missing is the evaluation of the purpose of this object, of these exercises, if these exercises are useful for patients. So these computer devices could implement 2D and 3D tasks in this virtual environment. So we could reproduce these exercises, we could monitor these exercises, we could create some impossible scenarios where the behavior of the patient could surprise us. We can also create new methods of interaction and relationship, and we can also do this in the distance. So we need a tele-neurorehabilitation process. In tele-rehab, the patient works in his home and the therapist can check the results in a certain distance. The neural learning project that we're working in is focusing on cognitive rehab. Maybe I'm not doing very well with time. Is that what you're coming to tell me? Okay, I'm sorry. I'm going to speak even faster. I'm going to try and explain the system as fast as possible. There is a rehab process where we use some tasks, some data. The therapist can program a 2D or a 3D task. The patient carries it out, and the therapist can analyze the results. We will soon show a demo so that you can see how it works. And while we see it, I will explain what we will do. Mar, please, could you please help? So Mar, who's at the back of the room, will just run the application.
Vale, entonces esta sería la aplicación tal y como la ve.
This is the application as the therapist sees it on the screen. So he is in his office, he programs a task for the patient, and I wasn't able to see that, but probably that's a 2D task. And here we have the patient who is at the Goodman Hospital, or he's at home, and he sees this screen. And then he has all of these tasks projected, the task that Mar has just programmed. And here he has a chore to do linked to visual memory. So here we have all of the different tasks that he has to do. This is a 2D task. This is the typical memory game of pairing these different cards. This is the idea. Once he finishes the task, he will obtain some results, and the therapist will be able to check those results whenever he wishes. If there are too many mistakes, then we will program some rescue tasks where we will decrease the degree of difficulty, or if the patient is doing quite well, we can increase that level of difficulty. Mar has finished here. She did a very good job here, 100% of positive results, and the task is over. And we could program a 3D task exactly in the same way. We're not doing very well with time, so don't program it, please. Let's get in the 3D immediately. So here we are in 3D. And well, we're doing this very quickly, but the patient would see this. Here we have a virtual environment. This is a kitchen. We're preparing a supermarket environment right now. The patient needs to have the shopping list, and the therapist programs this list of all of the objects when he decides what the patient should do. So in the menu before, we said, okay, we have to keep 2 or 3 objects, and he points out which objects should be kept aside. And we can have an interruption, such as the telephone ringings. And then he goes to the telephone. This is very important because this is an interruption mechanism. Alberto will will mention this.
So progressively, objects are kept. Other manipulations are possible as well. You can open a tap, cut up or slice up a tomato. The idea for this scenario is to be as close to the real one. Opening up a drawer to take a knife, slicing up a tomato. Since the fridge is open, you don't have to open the door. We'll be slicing it inside the fridge. I hope you've seen it. Now it's a sliced tomato. These are the bits which can be displaced as the original tomato. Opening up a stove, or we didn't pay attention to the telephone. Stove is on. Of course, now it's hot. You have to control the degree of burning. You can open up taps, etc. To conclude, Alberto will tell us what comes next. I'll be brief. Danny's shown you this tool, which has been developed with the cooperation of the 2 universities, with a number of technical partners, simply to show you how, at present, which sort of results are being obtained in the clinical implementation of this project. Let me tell you the reasons why we're doing this. Patients with brain injuries have very important cognition problems, and their quality of life is impaired, which makes it difficult for them to go back to work or to society. The type of patients with whom we've used these tasks are patients with cranioencephalic traumas or strokes. Right now, the patients who've tried out the system in the Goodman Institute and in other centers are 307 patients. Of these, 268 are patients in the Goodman Institute, people who've been seen in the last couple of years, and in 2 centers which are doing the pilot tests. And as you see, they've been with us with less time. And the number of patients who've benefited from these techniques is smaller. When we look at the efficacy of a treatment, one of the goals is to improve the task, but not only that, but also to have an improvement in their daily life, so that their quality of life is far better. Out of the 307 patients, the reports indicate that 223 patients have shown improvements, but 84 are in the non-improvement group. These are patients who do slightly better, but qualitatively this is not great. Tests are done. A number of neuropsychological tests are done, and neurophysiological tests are done as well, before and after treatment. And we want to know the repercussion of the treatment in their real lives. A number of scales are administered, and there are differences between the improvers and the non-improvers for attention, for memory, for planning ability, and also the last scale allows us to see an overall view, an overall appraisal of the competence of that individual. And we see important differences in daily activities, as well as social abilities, relations with others, relatives, and so on. We are realizing that 73% of the people who've gone through this treatment with the tools that have been mentioned by Daniela achieve a level of autonomy which is quite acceptable. What's most interesting for us, and we rejoice, of course, ourselves for having helped these people, but what we are concerned with is what about the other 27% of non-improvers? What went wrong there? What can we do to help them? Presently, we are working on this platform in several places. There are 5 centers in Catalonia, and for the rest of the state, we will be going to Andorra, in the State Center for Brain Damage in Madrid. And this is part of a project which is called Neuro Learning, and there is an international project going on as well. Thank you very much for your presentation.